Hello everyone. Today we go through about the introduction to linear regression. So this is a basic introduction. What is linear regression and how these models are trained and so on. So in the linear regression, what it is going to do is a kind of a regression problem that it is trying to predict a number. So in supervised learning, there are two categories, as you know, a classification and regression problems. Classifications is trying to predict a label or a class, where regression is trying to predict a number. So here we have given an example. So we are asked to find the correlation between the study hours and exam score. It has some noise in the data as well. So we have provide this data to the machine. So machine is trying to create a model. So in previous we learned a model is a mathematical equation or set of rules that machine is trying to find a relationship between the exam score and the study hours. So in the simplest form, so it tries to find a linear regression. Since we are learning about linear regression, so it's trying to create a equation y, or the predicted value, or we call it as the label, equal mx plus c, or w naught plus w1 x. So x is the feature. So if we are given this kind of a data set, we call the inputs as features and the output as a label. So there can be many features provided, and also there can be many outputs provided as well. We can split it. If there are several outputs, then we can split those to different linear regressions. As an example, if we are trying to create models for two outputs, that means we are need to solve two linear regressions. So here the machines will try to find out what's w naught and w1. Here the predicted value, or the exam score, will be the y, the predicted value, and then x will be the study hours. So then what machine is going to do is, it is trying to identify a pattern between these data. So first it will randomly guess the w naught and w1 and start with a random number, and it is trying to minimize the error. So when it is trying to minimize the error, there are different ways that we calculate the error. In the linear regression, we use mean square error. So in the mean square error, what it does is, we are get the difference of the actual value and the predicted value, square it, and we are getting the mean value, or number of data points that we have, and getting the error. So here you can see that our training data. So we capture what's the difference between the predicted and the actual. You can see small red lines here, and then we square it. And in the linear regression, we are trying to reduce that error and trying to accomplish the best fitted line. So we'll go through how this is doing in the next video. So that's about the more of mathematical and programming. So here it's more of a concept. So then it will try to create the model like this. So keeping this mind, so we can't create 100% accurate models. So we need to create a model which is more accurate. So here also you can see, so we will find a line y equals 51.46 plus 4.98x. So w1 will be 4.98 and w0 will be 51.46. So this y equal w0 plus w1 plus x, and these notations are written by different formats in different people. So some say it's y equal mx plus c, or y equal theta naught plus theta 1 x. Likewise, there can be different ways the equation is written, but it's the same. And then a linear regression, can it be only one feature? No, there can be two or more as well. Here it's a problem with the two features, the size, square feet, and the bedroom. The example is like, we are given the house prices with the house square feet and number of bedrooms, and we are asked to predict the price with the size and the bedroom. So then we need to extend the equation as this. So it will be w0 plus w1 x1 w2 x2. w1 will be the one feature and w2 will be the next feature. So in this case w1 will be the sorry x1 will be the house size and x2 will be the number of bedrooms and predicted value will be the price. So if we have a one feature, it will be only a two-dimensional plane feature and the expected value. But if we have two different features, it will be a it's a three-dimensional plane. So here we identify a line. Here we need to find the a plane where it solves the equation, or that plane will be the actual model that machine will try to create. So that's it for the linear regression. So in the linear regression, as a summary, what it's doing is it is trying to create a mathematical equation to predict the label with the input values, and it is trying to identify these parameters, which is the constant and the slope of the different variables. So in the linear regression there can be multiple features, so we need to create single linear regression for a single output. If we are given two or three different output or the label, then we need to create two or three different linear regressions. So in the next session we'll go through the R square. So there are different things. Let's say the final thing is you will be given other parameters as well, maybe 1,000 different features. So we need to identify what are the features that are relevant to the equation. So that's will be done with R square, and all these things will be covered in the next. Thank you all.